Good afternoon, everyone. Sorry about the Zoom difficulties. I'm Dr. Justin Glisan. I'm the state climatologist of Iowa, and I work for the Iowa Department of Agriculture and Land Stewardship, the Climatology Bureau. What we'll look at today are current conditions on the ground across the state and then spring outlooks moving forward for the growing season. Now that we have 2019 in the rearview mirror, what we'll look at are current conditions across the state. Now, some of the current conditions that we'll discuss, especially subsoil moisture, are a direct result of the wetness that we saw in 2019 and even going back into 2018. The first set of slides that we'll look at are the percent of normal precipitation across the state for the last 30 days, in the last 60 days. Then we'll look at soil moisture, the amount of moisture within the subsoil layer, and then soil temperatures at 4 inches. This gives us an idea of how soil temperatures are warming given longer days and more daylight and getting into the warmer part of the year. Then we'll look at stream flow. Stream flow is important because it tells us by proxy about soil moisture, but also melting snowpack to the north of us. And then I'll actually show you the snowpack and the SWE, or the snow water equivalent, that we see in that snowpack, especially on the Mississippi Basin side. This will impact short-term flooding, and I'll highlight some short-term flood risks a few slides from now. First, we'll look at recent temperatures and precipitation. So recent meaning the last 30 days for temperature, and then the last 30 to 60 days for precipitation. Our first plot here is the average temperature departure from climatology, or the 30-year average of what we expect for this last 30 days. And what you see are warm colors. And what this tells us, across the state, we were anywhere from 1 to 2 degrees above average temperature-wise. So we've had a warm stretch of 30 days. Now, if you go back 60 days, we actually see a similar plot. This suggests that we have been warmer than average for a majority of days in the last 60 days, or the last 30 days, as this plot shows. And this is good because warmer days with wind actually help evaporate some of the moisture out of the subsoil, especially that top layer. And that's important as we go into the growing season and plant 20. The next two plots I'll show you are the 30-day and 60-day percent of normal precipitation. This gives us an idea of what parts of the state have received more rainfall and snowfall, and what parts of the state have missed out on precipitation. Our first plot here is the last 30 days. And what this shows, the cooler the colors, the greens and the blues, and getting into the darker blues, that's where we're above average percent-wise for precipitation. Wherever you see yellow, those lighter yellows into those brighter yellows, that's where we see departures or drier conditions. What this figure shows is that across much of the state, we've had above average precipitation. Now, when you see that light blue color, that's anywhere from 150 to 200%, so twice the amount that we would expect across the state. We only see dry conditions in a few spotty parts of northwest Iowa and in that southwest corner. The interesting thing about this plot is it's radar indicated. So we have radars in Omaha, Sioux Falls, South Dakota, La Crosse, Wisconsin, in the Quad Cities, and St. Louis, Kansas City, and then Des Moines. All those radars sense precipitation falling, and then we put them all together. We composite them, and that gives us this map for the last 30 days. This plot is for the last 60 days. So this is the last 60 days percent of normal precipitation across the state. What you see at 60 days is we start to dry out. wherever you see the yellows to the browns, that's where we're starting to see deficits of precipitation build up. And this is important in monitoring dryness, but also in monitoring wetness across the state. So again, the target areas that we've seen some drier conditions form are in that southwest quadrant, and then a little section, Lyon County, up in northwest Iowa. So yes, at 60 days, we do see some dryness creeping in, but this goes back into the drier part of the year for Iowa. So it doesn't take a lot to get above or below. Now, as we move into the growing season, as precipitation, rainfall starts to pick up, that's where we start to look for where dryness is continuing or where we're starting to get wetter than average. Now, closely tied into the amount of precipitation that we get across the state, and then also north of us, since all that water will feed into the river systems and move south, are soil and stream conditions. So the next few slides, we'll look at soil conditions in terms of moisture and temperature, and also stream flows, how much water is flowing through our stream systems across the state. Okay, first things first is subsoil moisture. So as you know, when you watch the morning or the nightly news, we have forecast models that tell us how the atmosphere is going to behave. High temperatures, low temperatures, if it's going to rain, if it's going to snow, and those go out 7 days. Well, we have similar models for the surface, land surface models, in fact, and they help us determine how much subsoil moisture there is. So the plot on the top left is a percentile ranking. Now, when we talk about percentile rankings, this tells us how wet the subsoil is. So the greener the greens, the wetter the soil is. When you see those really dark greens, that means record subsoil moisture for this time of year. Now, across the state, we're anywhere from the 90th to 95th percentile, with some drying portions in southwestern Iowa and southeastern Iowa. The easiest way to explain this is you think of a sponge. A soaked sponge would be 100% capacity, so no more infiltration capacity if we do get into rainfall events. Being at the 90th or the 95th percentile, that tells us that the soil has been drying some, but there is anywhere from 5 to 10% holding capacity for any kind of precipitation event that we would get. So wet soils is the key point here. Now, the first half of March, we were able to start drying soils because we were warmer than average, but also we were in a dry streak. That kind of changed as the storm track changed in late March, and we started to get rainfall events, even snow, every few days. So it kind of prevented more drying than what we would like to see. This gets into the second plot on the right here. This is the delta plot, or the anomaly change. So this tells us, given today, or yesterday I should say, versus the end of the month of March. So six or 7 days, wherever you see yellow, that means we're actually drying the soil. So a 10% reduction. We are drying. Now we would like to have temperatures and weather like we're having this week to further dry the soil so we can get our farmers out in the fields. But yes, in parts of the state, especially in southwest Iowa, farmers are rolling given the drier conditions that we saw in the precipitation field, as well as subsoil moisture. Now, this is a secondary product of soil moisture. Again, this tells us how wet or how dry the subsoil is given a specific land surface model. The key takeaway here is wherever you see blue or those purple colors, that's where the subsoil is wetter than average, or wetter than it should be. Wherever you see that white creeping in, you're starting to get into the normal subsoil conditions. Again, you look at southwestern Iowa, you see some white developing there, even southeastern Iowa, with lack of precipitation in those two parts of the state out 60 days, we are able to start drying the subsoil moisture. So yes, we would like to see this continue. Now, tied into soil moisture and precipitation is what we call 20-day average stream flow. So over a 28-day period, the average amount of water moving through our streams is recorded at these river gauges, and they give us an indication of how much water is flowing through the system. Now, given the wetness of the subsoil, 90th to 95th percentile, as I said, pretty near capacity, a lot of the rainfall, a lot of the precipitation that we get doesn't soak in. It runs off into our streams. So anywhere where you see green to blue dots, that's normal to above normal stream flow. So those darker color blues are where you're seeing more water moving through the stream system. This is evident on the Missouri River Basin side with the Iowa-Nebraska border. Also some interior stream flow, interior streams across the state. But generally, we're trending normal to slightly above normal, and with a few stream gauges that are much above normal. Again, this gives us an indication that the subsoil is wet, and in certain parts of the state, we've had more rainfall, which feeds into the river system. So we use this as a proxy for wetness and dryness monitoring, because on the flip side of this, you can start to see stream gauges getting into the warm colors, orange to red, and that indicates that rainfall has been dwindling, for example, and that there's not enough runoff into the streams to promote a normal or above normal water through the stream system. Whenever we see those reds pop up, that's giving us an indication that dryness is enhancing and that we might get into drought consideration, which is something that myself and a group of experts across the state monitor for the U.S. Drought Monitor author every week. Okay, so the next plot we're looking at is the 4-inch soil temperature. And this is as of yesterday, April 6th. And this is courtesy of the Iowa Environmental Mesonet, run up at Iowa State. Each county, as you see, has a number there. And these are based on the National Weather Service North American model. It's a land surface model that gives us an indication of soil temperatures, much as an atmospheric model would give us highs and lows. What we're seeing as you transition from the northeast, coldest part of the state down to the southwest, soil temperatures are generally in the upper 40s and then getting into the 50s across southern Iowa. Now, this is due to the fact that we've had warmer weather recently, and these soil temperatures will continue to increase throughout the week until about Friday when we get a cold snap. And we'll talk about that later in the short-term outlooks. A note of these plots, they're generated every day, and you can go back into the archive and actually see how the trend is moving, whether soil temperatures are gradually rising, whether there are hiccups, ever so often we get a low pressure system that comes through, dumps snow on parts of the state like we had last week that can impact soil temperature. So yes, these are available every day, and they are good guidance moving forward, especially into the growing season. So we talked about soil moisture and stream flow. Those two are pretty closely tied into snowpack and the amount of water available within that snowpack, especially in the upper basin of the Mississippi and the Missouri. Given historically wet conditions across the upper Midwest, including soil moisture, any kind of melting will be routed into the stream system, and then that water will make its way south into Iowa. And so that's where we start to get into flooding concerns. So the first part that we'll look at is the amount of snowpack in existence in particularly the Mississippi Basin. This plot here is one of my favorite plots moving from winter into spring because it shows us the amount of above or below average snowpack across the upper Midwest. Now I'll draw your attention to the black line in western Iowa, going all the way up north into North Dakota. And then if you look over at Champaign, Illinois, that black line moving through Indiana and then near the border of Ohio and Michigan, those two lines represent the Mississippi Basin. So any snowpack that you see on that map will melt and flow into the Mississippi River. What this plot shows us is where you see warmer colors, yellows, that means that part of Minnesota or even Wisconsin in the upper peninsula of Michigan are below average snowpack for this time of year. Now, on the opposite side of that, wherever you see blue, that's where we're seeing above average snowpack. When we see above average snowpack, especially this time of year, given that we're starting to warm up, we know that this water, once it does melt, will flow into the Mississippi Basin and actually move its way down into Iowa on the eastern border with Wisconsin and Illinois. And that's where we start to think about flooding. We always expect some sort of flooding given snowpack melt from winter to spring, but the amount of snowpack will give us an idea, along with soil conditions and existing stream flow, how much flooding and how severe it could get. Now, if we actually look at the amount of water that's available in the snowpack, so if you melted all that snowpack down, how much water would you get out of it? Wherever you see those darker blues into purples, you can have anywhere from 8 to 14 inches of available water that will eventually make it into the stream and river systems. Now, yes, there's a lot of water available up there in that snowpack, but given our short-term outlooks again, which I'll talk about later, we're not expecting a rapid melting event. We typically like the 40-20 rule during this time of year, especially in March, moving into April. Highs in the 40s during the day, lows in the 20s at night. So you get gentle melting and refreeze each night, so you're not inundating the river systems with a lot of water. So now that we've looked at subsoil moisture and we've looked at stream flows and then the existing snowpack across the upper part of the Mississippi Basin, we can start to look at short-term flood outlooks. Now, when we talk about short-term, we're talking 7 to 14 days. And where we're going to emphasize the risk of flooding is on the Mississippi side. Thanks to our friends at NOAA and the United States Geological Survey, we have this plot that shows short-term maximum flood category forecast. So these are river gauge forecasts for the next 7, 10 days that give us an indication of existing flooding or flooding that will occur moving into the short term. So I'll draw your attention to the western part of the state, and you'll note no real colors. We're not really indicating any kind of flood risk right now. Maybe some minor flooding in southwest Iowa, but nothing like we saw last year. Where I will draw your attention is the eastern border, the Mississippi. You see stream gauges from the Minnesota-Iowa border all the way down to Keokuk, orange and red. Now, these indicate that minor and moderate flooding are occurring right now or are likely to occur. So if you actually go to the website, you can click on each of these dots and it will show you at a given location when flooding is expected to occur and what the category of flooding will be in the short term. So just out of curiosity, I pulled the river gauge at LeClaire Lock and Dam. Currently, LeClaire is in minor flooding, as you can see by the hydrograph, or that blue line within that orange color, minor flooding. Now, the river stage modeling suggests that given current conditions, we should expect a crest at moderate flood stage of 12.4 feet, somewhere between April 9th and April 10th. So this is 9 a.m. Thursday to 9 a.m. Friday. And then you can gradually see that line go back down into minor flood stage. This is an impact caused by melting snow across the upper Midwest, as well as recent precipitation. So yes, again, these are good tools to look at in terms of your location and whether you can expect flooding moving forward into the short term. Now, we also have longer term modeling for our river gauges that go April, May, June, as we're currently in April. Those indicate the possibility slightly greater than 50% for major flooding to occur on parts of the Mississippi, effectively south of Dubuque down to Burlington. Now we'll have to wait for conditions. We'll have to wait for the snowpack to see where our river gauges are going to go. But again, the short-term flood risks give us a good idea of what current conditions are, especially north of us. So finally, I want to thank you for sitting through this presentation. I hope you find the information beneficial. I hope you've learned some new tools that you can use moving forward for your own farms, for your own businesses. Here's my email, justin.glisan@iowaagriculture.gov, and my telephone number, and again, the Climatology Bureau website. Please reach out to me if you should ever have any questions. I'm always happy to talk. If I can't get you the information you need, I'll find somebody who can, but I'm here as a resource for you. So please use me as a resource and contact me if you ever have any needs or questions. Thank you.